So hi everybody, I'm Filippo Menczer. I'm in the School of Informatics and Computing and Engineering next door, and I will give you an overview of some of the research that we're doing in our lab on different aspects of misinformation. We're interested in the spread of misinformation, and we're interested in studying different factors that affect that spread. So I'll give you an overview of a few of the things that we think play a role. And so let me start by saying that, and this is no surprise to you, some misinformation spreads virally, and that's what those distributions show. If we look at the distribution of the popularity or the virality of a piece of information that is shared, whether we're looking at it on Twitter at the top plot or Facebook at the bottom, and we compare the popularity of reliable information, real news, or various types of misinformation, we see that these distributions are very similar to each other. They're almost indistinguishable. In other words, the chances that some piece of misinformation will go viral online is just the same as reasonable information. If we look at the tail of that distribution towards the right, those are the things that are spreading most virally. So for example, you can see on the top plot towards the right, you see things that are being shared tens of thousands of times. So let's pick just one example of that to visualize it. This is one piece of fake news that was spreading around the elections virally on InfoWars. This one was a claim that the Clinton campaign was engaged in satanic rituals, and it spread wide and quickly. On the right, what you see is a representation of what we call a diffusion network. So this is a network in which the nodes represent Twitter accounts, and two nodes are connected with a link, which is a little bit hard for you to see, maybe. If one retweets the other. So if Susan posts something and Alan retweets her post, then we draw an edge between the two Twitter accounts. And so some of the things that we can observe in this kind of network are interesting and quite obvious. First of all, we see that some nodes are really dominant. Here, the bigger nodes are ones that are retweeted many times. So those very big nodes that you see there, those 2 or 3, in fact, they are controlled by, the Alex Jones, who is spreading this particular piece of news, the person who runs that website. Another thing that you notice is that some nodes are different colors. So we are coloring the nodes with to represent the likelihood that an account is a human versus an automated account or a social bot. So the red nodes are the ones that we believe are more likely bots. And so what we could see is that there are a bunch of accounts that are quite bright red, and they are retweeted by quite a few people. So we infer from that bots play an important role in injecting information and getting it in front of a lot of humans. Okay, so I said that I would talk about 4 different factors that play a role in the spread. So number 4 is competition for attention. So this is sort of falls under the category of cognitive biases. So Alan presented very convincingly one of these factors, which is confirmation bias, and we agree that that's a very, very important piece. So this is another one, even more basic if we want. So instead of just looking at bias that comes from a person's ideas, we're looking at what happens just because we have limited amount of attention. We can't see everything that is out there. The platforms rank things and tell us what we can pay attention and what we cannot. And so what we do in the lab is we design some models, some agent-based models that try to reproduce some of the characteristics of the social network. So we have nodes that share things, so they can reshare things posted by their friends. They have a screen in which they see what their friends post. Okay? And so we have, in one of these models, we wanted to ask, what is the likelihood that something that is lower quality spreads widely compared to something that is high quality? And we are making the assumption that people prefer to share high quality things. So in this model, the probability that a user shares something posted by a friend is proportional to the quality of that piece of information. Here, quality could mean anything: accuracy, interestingness, whatever you want. So what we find is that there are 2 important parameters that affect what happens. One is whether people are flooded with information. So on the x-axis, you cannot see the label, I'm sorry, but there is the amount of information that is generated. So if it is higher, then people are more flooded, they're overwhelmed, they cannot see everything, they can only see a small portion of the things that are posted by their friends before they decide what to reshare. On the y-axis, we have the amount of attention. How many things people see before, on their screen, how many item or post people are able to evaluate before they decide what to share. So what we find, and the color represents the correlation between quality and popularity. So we want that to be high, right? Meaning that good stuff is more likely to spread virally. And that's true when there isn't too much information overload and or there is plenty of attention. So in those cases, most of the things that are shared are high quality. That's represented in that network. The size of the node represents the quality of the meme that is shared by that person. But when you have more sort of information load and or limited attention, then a lot of the things that are shared are low quality as represented by the small nodes in that network, and the correlation between quality and popularity goes down. So this says that even just for the reason that we are overloaded and we can't pay enough attention to everything, even if we prefer to share good quality stuff, still a lot of low quality stuff will spread. Number 3 is algorithmic biases. Well, as I said, since you cannot see everything, what you really see is determined by the platform, because they rank things and you're only going to probably see a portion of them. So what are the factors that platforms use to decide what information you're exposed to and what you're not? And we've looked at data about web traffic from very large number of web browsing sessions, and we can look at all the clicks that people make on the web coming from a particular source, going to another, to some website, going to another website, or you coming from an app or a platform, let's say Facebook, Twitter, Instagram, or even a search engine, or even an email client, and where are people going when they are coming from those platforms. And we can measure different kinds of biases. For example, how much is the traffic concentrated coming from a particular source to some subsets of the possible sources of information. We call that homogeneity bias, this concentration, where your attention is focused on a few sources. And then popularity bias is the tendency to send traffic to just the most popular websites. And for all the platforms that we've analyzed, we tend to observe a presence of popularity bias or homogeneity bias that is larger than what we would expect in a null model. If you have questions, I can tell you what the null model is, but let me move on. And by the way, those biases are even stronger when we're focusing on websites for news, when people are browsing for news. We also build models to try and look at whether an emphasis on popularity by the platforms is able to bring the quality stuff up. That's the assumption of the wisdom of the crowd, right? If a lot of people like something, if that picture has a lot of likes on Facebook, then Facebook is going to put it up at the top to make sure that you see it, right? Well, depending on what I call exploration cost here on the y-axis, which is the sort of how many things you're going to explore, the bias towards showing things that are popular can either hinder or foster the spread of quality information. In general, it actually hinders. So what that popularity bias does is it amplifies some noise. Something becomes a little popular somehow, either because it's promoted somehow or just by random fluctuations, and then the platform amplifies it. There is a narrow region, that yellow color in the middle, for a particular critical amount of exploration costs for people who look at just the right amount of things, let's say, on their feed. Then some amount, not too much, but some moderate amount of popularity bias actually helps, because it sort of takes the signal and amplifies it so that quality stuff more quickly gets spread. So the take-home message here is that different types of algorithmic biases can either help or not, and it really depends on sort of complex factors. Number 2 is social biases. This is stuff that you've all heard about a lot of times. It also connects to the issue of confirmation bias. This is data from a study that we did on Twitter a few years ago. We looked at people tweeting about the elections, and it turns out, not surprisingly, that conservatives retweet other conservatives and progressives retweet other progressives. So some people refer to this kind of stuff as filter bubbles or echo chambers. So this is already bad by itself, because it means that you can target a message to leverage confirmation bias. And also you may not be exposed to information that challenges your views. But we also want to ask, what is the role of the platforms in creating this kind of structure in the network? So we have developed a model a very simple opinion dynamics model where, just like the one I described before, but here the nodes represent people with political opinions, and the color represents the opinion, which initially is uniformly distributed between blue and red, or liberal and progressive. And this model makes just two assumptions. One is that when you see something posted by a friend whose opinion is not too different from yours, you can be influenced a little bit by that opinion. And the second thing is that you can unfollow somebody who posts something that you really strongly disagree with, right? That uncle that posts that offensive message, you know what, I'm gonna unfriend him on Facebook. And so that's what you see with the dashed lines. Those are connections that are broken. In this model, they are replaced with random connections. If you just have these two ingredients and nothing else, and you let the model run, the same thing happens every time. So people sort themselves out in groups, and these groups become eventually segregated and separated so that you're more likely to be connected with somebody else that has your opinions, and so therefore can confirm and reinforce your opinions. And also, the groups become more homogeneous, so they become more similar to each other. So we see both polarization and segregation. So let me just, the last point, bots. This is one that we're very, very interested in. We study a lot how to detect bots and what is their role in the spread of misinformation. So we have a tool called Botometer. Anybody can use it to look at a Twitter account and see what is the likelihood that this account is automated. We also have another tool called Hoaxy, where we collect data from a lot of low credibility sources, as well as from some fact-checking sources, and you can search and look at how articles are spreading from person to person on Twitter. So you see networks like that. You can observe, this is, for example, a piece of fake news about millions of illegal aliens voting in the last elections. You can see that the people who spread the misinformation, which is the gray connections there, are mostly separated from the people who share the fact-checking, which debunked that piece of fake news, which are the links shown in yellow. You also see that there are some influential users. You also see some bots in red. And one of the things that these bots do is they mention influential users with links to the false news to get their attention. So let me show you a couple of things that we found when we analyzed this very large network, almost done. This very large network of people sharing either misinformation in purple or fact-checking in orange. Very large network with 14 million articles from low credibility sources, and about 1 million articles from fact-checking sources. Tweets, not articles. And when you get to the core of this network, you find that mostly it is made of people who share just misinformation. Occasionally they share a link from a fact-checker, but just to say that they're not to be believed, that they're biased, or to make it look like the fact-checkers are supporting a false claim with a link to the fact-checking site, assuming that people don't click on the links, because if they did, they would see that they contradict the very claim. We also see that we have more bots. The bot score grows as you move towards the core of this network. And bots follow some strategies. One I already mentioned, and it is the tendency to mention or reply to very influential users with lots of followers. One is that they act very early on in the first 10 seconds after a piece of misinformation is posted. And so that's how they get it in front of a lot of eyeballs. And another one is that they can just repeat the same claims. Like the same account can repeat the same claim thousands of times. And unfortunately, users, humans, retweet content posted from bots. Most of the retweets are generated by humans. That's what the plot at the top says. But if you look at whom do the humans retweet, the plot on the left is they retweet humans, but they also retweet other bots. Okay, so in summary, we believe that there is a complex interplay between cognitive, social, algorithmic biases that make us vulnerable to information, and social bots can exploit these vulnerabilities. And we need to understand these complex systems in order to devise countermeasures. I also want to thank all of my great students, postdocs, and colleagues who are actually doing this research, and some of them are in the room. Thank you. Okay,